All right, section 8.3 is working with special right triangles. We're going to be looking at 45, 45, 90 triangles and also 30, 60, 90 triangles and looking at the different relationships that we see within the sides. On the in-class assignment that we did for section 8.2, I had you trying to find the third side of a right triangle given two sides and worked with using the Pythagorean theorem to do so. And if you notice really closely is that of the first couple of triangles, they all triangles had two angles of 45 degrees, and then they had the 90-degree angle. That's what we call 45, 45, 90 triangle. And the other set of them had a 30-degree angle, a 60-degree angle, and the right angle. And hopefully what you were able to find is a couple different relationships. So first of all, we're going to look at a 45, 45, 90 triangle. Just kind of as a little bit of review, the fact that we have two angles that are congruent to each other, that means that our triangle has to be an isosceles triangle because of the isosceles triangle theorem. If the angles in a triangle are congruent, that means its opposite sides have to be congruent to each other. So in this case here, I'm going to use n to represent the side lengths here, and they're both the same. Well, the fact that both of those side lengths are the same, if we want to figure out what the hypotenuse is, we could use the Pythagorean theorem. I know that these two sides here, if I square them, n squared plus n squared has to equal my hypotenuse squared, which is c squared. N squared plus n squared would give me 2n squared equals c squared. To solve for c, I can take the square root of both sides, and this gets into a little bit deeper working with radicals, but something that I think you can pick up from here. The fact that I'm taking the square root of 2 times n squared, I can break this apart. And the square root of 2, we do not know what that is off the top of our head, so we're going to leave it as the square root of 2. But when you take the square root of a square, which we have here of n squared, that square is going to go away, and we're going to get n. And this is going to leave me with n squared roots of 2, and that's going to give us what our hypotenuse is. Whenever you're working with a 45, 45, 90 triangle, the hypotenuse is always one of your side lengths times the square root of 2. On the next slide, I have it written out here. So the first thing that we need to understand here is, like I mentioned, is that the legs are always going to be congruent to each other when working with a 45, 45, 90 triangle. Here I both have them as n. And the hypotenuse is always going to be the length of one leg times the square root of 2. So n is representing the length of the leg, and then I have it times the square root of 2. So let's say that n was equal to 10. Well, I know that the other leg would have to equal 10, and then my hypotenuse would be 10 square roots of 2. And we can fill that in. So I'm going to look at two examples real quick of 45, 45, 90 triangles. One that's a little bit easier to solve, and one that you're going to have to use a little bit of algebra to solve for. So here we have a 45, 45, 90 triangle. I'm given one of the sides. I know one leg is 5, so the fact that both legs have to be the same, I know that the other leg has to be a 5. The legs are always the two sides that are opposite of, or on both sides of your 90-degree angle. Since we have two legs of 5, my hypotenuse is always the leg times the square root of 2, so now I know that this is going to be 5 square roots of 2. The nice thing about these special triangles is you don't have to show any work. You don't have to use the Pythagorean theorem. We don't have to worry about using a geometric mean. We can just go ahead and assume that information as is. Now the next example that I'm going to look at is a little bit more challenging here because I'm not given what the two side lengths are. And here I'm given that my hypotenuse is 8. Well, if this was 8 square roots of 2, I would be able to say, okay, then both of my legs have to be 8. The problem is that we're not given 8 square roots of 2, we're just given 8. So I'm going to use the idea of solving this algebraically to figure out what our side lengths are going to be. You can also use the Pythagorean theorem, which I'll show you in a minute. So the fact that I know that I have 8 here, and this 8 equals n times the square root of 2, because that's what our hypotenuse is. I know that my two legs are both going to be n. So if I can solve for n, that means I'm going to be able to know what my two lengths of my sides are. So I'm going to set up an equation. 8 is equal to n times the square root of 2. Solving for n, if I divide both sides of my equation by the square root of 2, I end up with n equals 8 divided by the square root of 2. Well, this is great, except when we went over our reviewing of radicals, we don't like square roots in our denominator. So I'm going to multiply the numerator and the denominator by the square root of 2. This now gives me 8 square roots of 2 divided by the square root of 4. And so I get 8 square roots of 2 divided by 2. Because 8 divided by 2 is 4, I end up with 4 square roots of 2. This is my value for n. This means that both of my sides of my triangle are going to be 4 square roots of 2. If you're not quite seeing how I did that problem, what I would suggest doing is going back, watching this again, and seeing if you can see where the algebra comes from with this problem. The second option for solving this equation is with working with the Pythagorean theorem, if you would rather do that. And how I would use the Pythagorean theorem is I would set this up as knowing that my two sides are going to be n, and I know my third side, which is the hypotenuse. So I'm going to take both legs, so n squared plus n squared is equal to 8 squared. Setting this up now, I can take n squared plus n squared, which is 2n squared, is equal to 8 squared. 2n squared is equal to now 64. And if I divide both sides of the equation by 2, I get that n squared is equal to 32. Now with this problem, I'm trying to solve for n because that's my two side lengths. So how I can do that is getting rid of that square. I can take the square root of both sides. Now I get n is equal to the square root of 32. The square root of 32, we can break that up into the square root of 16 times the square root of 2. Square root of 16 is 4, and so I get 4 square roots of 2. This length right here is what's going to be our two side lengths. And it's the same thing that we came up with in the previous problem that we were working with. So again, you have two different ways that you can do this. You can solve it algebraically, or you can use the Pythagorean theorem. And it doesn't matter to me which way you solve it, whatever way you feel or you think is most comfortable for you. Try and watch both the problems being done again so you can choose which one you prefer. So now that we've talked about a 45, 45, 90 triangle, now we're going to talk about the relationships between 30, 60, 90 triangles. First thing, just kind of a review. Because of the angles in our triangle, remember that if you have two angles that are different from each other, the smallest angle, the side opposite of that, is always going to be the shortest leg, and the side opposite of the largest angle is going to be the largest leg. Now, with 30, 60, 90 triangles, we don't have something where both sides are the same, and then our hypotenuse is one side times square root of 2. It's a slightly different way. But the one thing that's interesting is the fact that all of our sides here have a relationship to that shortest side that we have. And so what we're going to be looking at is the shortest side. That's what everything's going to be in relation to. So that's what I'm going to let be n. The hypotenuse of and I'm going to go to the next slide right here because here is where I have it all. So it says all sides have a relationship to the shortest leg. And so my shortest leg is opposite of the 30 degrees. So I'm going to let that be n, my variable that I'm looking at. Then it says here the hypotenuse, it should be is always 2 times the shortest leg. So that means I'm going to take this shortest leg times 2. So 2 times n. The longest leg is always the shortest leg times the square root of 3. So I'm going to take my shortest leg of n and I'm going to multiply it by the square root of 3. And there's my three sides of a 30, 60, 90 triangle. Not as easy to remember as the 45, 45, 90 triangle, but they all have a relationship, like I said, to the shortest side, the side that's opposite of 30 degrees. So I'm going to go through two examples real briefly so that we can look and find out the side values of that. So here I am got a 30, 60, 90 triangle, and I'm given the hypotenuse. The fact that I'm given the hypotenuse, I know that the hypotenuse here is equal to 2 times the shortest leg. My shortest leg is opposite of 30 degrees, and my longest leg is my shortest leg times the square root of 3. So to find the two legs, I really just need to find n. Solving this algebraically, I can do that 2n has to equal 14. Divide both sides by 2, and I get n is equal to 7. This right here is telling me that my shortest leg of my triangle must be equal to 7, and that my longest leg then is going to be 7 times the square root of 3. And now I have my 3 sides to my right triangle. The last example here is another one that you're going to have to do a little bit of either algebra solving it, or you're going to have to use the Pythagorean theorem. It's your choice. And the reason we have to use a little bit of algebra is because the side that they give us here is the longest leg, which is going to be 8. Now, like before, if this was 8 square roots of 3, then it would be really easy to say that my shortest leg is 8, and then my longest leg here, or my hypotenuse, sorry, is 16, because it would be double the shortest leg. But since it's not times the square root of 3, we have to look at solving this slightly different. Solving it algebraically first, I know that 8 here has to equal n square roots of 3. My shortest leg is n, my hypotenuse is 2 times n. So to figure out what n is, I can solve this algebraically using this equation. So 8 is equal to n times the square root of 3. Divide both sides of our equation by the square root of 3 to solve for n. And now I have n is equal to 8 divided by the square root of 3. Now this is great except for the fact that we have the square root of 3 in our denominator. So we're going to rationalize our denominator, multiply the numerator and denominator by the square root of 3. So I get 8 square roots of 3 divided by the square root of 9. And simplifying, I get 8 square roots of 3 divided by 3. And so this right here is my length of n. So I know that my shortest leg has to be that, so I'm just going to erase this part. And I'm going to replace it with 8 square roots of 3 divided by 3. The hypotenuse is going to be double that. So if I take 2 times 8 square roots of 3 divided by 3, we're going to multiply straight across. And all I'm going to do here is multiply 2 times 8. So that's going to give me 16 times the square root of 3. 1 times 3 gives me 3. And so our hypotenuse, as we look at that, we get 16 square roots of 3 divided by 3. You have your longest leg of 8, your shortest leg of 8 square roots of 3 divided by 3, and our hypotenuse, which is 16 square roots of 3 over 3. So you're solving this in this fashion. You're using algebra to do so. Now the last way I want to show you is how to do this using the Pythagorean theorem. Setting up this problem to use the Pythagorean theorem, I'm going to erase solving this algebraically. All right, so we know that we've got one side, which is 8. Our shortest leg, like I said, I'm going to use n, and we've got our hypotenuse, which is 2 times n. Well, the Pythagorean theorem says that if we take each leg and we square it, so that'd be 8 squared plus n squared has to equal 2n squared. So I've got 64 plus n squared is equal to, now here we have to be a little careful, because you're taking 2n squared, so that means we're taking 2n times 2n, which is going to give me 4n squared. So I'm going to subtract both sides of our equation here by n squared. This leaves me with 64 is equal to 3n squared. And now I'm going to divide both sides by 3. Now this ends up giving me 64 thirds equals n squared. To solve for n, we are going to take the square root of both sides. When you take the square root of a fraction, you're taking the square root of the numerator and the denominator. So right now, n is going to equal the square root of 64 divided by the square root of 3. Now, as I set this up and I work through this, I need to rationalize my denominator, so I'm going to get rid of that 3, multiply the numerator and denominator by 3. So if I take 64 times 3, I get 192. So n is equal to the square root of 192 divided by the square root of 9, which in our case here is going to be 3. So now I just need to try and simplify working with 192. As I work with it, I'm going to just try 192, divide that by 16, that works. Let's see, 4, I'm going to try, let's just break this up. So I can do the square root of 16 times the square root of 12 over 3. So this is going to give me 4 square roots of 12 over 3. Oops, 12, sorry. And so now on that square root of 12, I can break that up. So we can do 4. One second, let me get the pen working here. Okay. So I can do this 4 square roots. Having some difficulties with my pen. I don't know what's happening here. All right, so I'm going to have to do this verbally rather than showing it to you. Sorry, because something's not right with my pen settings on the computer. All right, so if I take square root of 12, I can break that up to, actually I'm just going to try and see if I can get a new page and see if I can get this to work. Okay, there we go. See if I can go back. There we go. Now it's working. Sorry. So we've got 4, and then we can do the square root of 4 times the square root of 3 all over 3. And this is going to give me 4 times 2 times the square root of 3 over 3. And here I'm going to end up with 4 times 2, which is 8. And I get 8 square roots of 3 over 3. And so right there, what that's doing there is that's telling us what our shortest leg is. So n is equal to 8 square roots of 3 over 3. If we double that, if we take 2 times that to find out what our longest side is, so 2n is going to equal 2 times 8 square roots of 3 divided by 3. This is going to end up giving me 16 square roots of 3 over 3. So we have our shortest leg, we have our hypotenuse, we have our longest leg. Those right there are the 3 legs to our, or the 3 sides to our 30, 60, 90 triangle. When you're working with the Pythagorean theorem, my suggestion to you is to try and work these out algebraically, just because it takes a little bit less time, there's less room to make mistakes, and you don't have to do all the simplifying with the radicals, because it's pretty much done for you. But it's always something that you can resort to if you can't remember what the 30, 60, 90 rules are. But what I would suggest doing, once again, if there's something that you're not quite sure of, try and go back, re-watch any part of the video, and take any notes, and then we will practice these in class tomorrow.